and we need to know just one point, x1, y1, and just one slope, the only slope of your line. Plug it in, and you're done. You've written the equation of the line. You've also written equations of quadratics. You need, well, with quadratics, our format is this one. So if you knew your vertex, HK, and you knew another point, XY, you could plug it in to find A. Or we have this plus or minus 1 over twice the distance between focus and directrix. So we've written equations of quadratics. If you know the focus and the directrix, we've kind of used that formula to write equations of quadratics. We've written equations of polynomials, and that's our y equals a, x minus r with a multiplicity, x minus the root with a multiplicity, and so on. So if we just know all of our roots and then know one other point, we can plug in the point and then find a. Okay? So this is no different than skills we've needed to know as well for different types of functions, how to write the equation based on some points. So our format for this is y equals a times b to the x. Now, some of these are easier than others. I'm going to show you this first one as if it's the most complicated version you're ever going to see, and then I'll show you how we could have known the equation from the start anyway. You need 2 points for exponential graphs. Like lines, you only need 1 point in the slope. Quadratics, you kind of need the focus directrix. Polynomials, you need a bunch of roots and a non-root point. Here you just need 2 points. And so what we're going to do with the 2 points is we're going to plug them in twice. It's almost going to be like a system of equations. So we're going to plug in, and let's pick any 2 points. I'll pick these two. 115. So into my structure, I'm going to plug in 115. For x and y. And then again, I'm going to plug in a point, and I'm going to line it up right underneath it. I'm going to plug in 245 for x and y. And the goal here is what is A and what is B. And so it's not a traditional system of equations that we solve by substitution or elimination. But what can we do to these two equations, not add them together, not subtract them, that will cancel out the A's? What can we do that will cancel out the A's? I don't want to do that. I probably could, but that might get trickier with trickier numbers. What can I do to cancel out the A's? Yeah, but you couldn't really add or subtract these equations because you've got like a multiplier in between. It's a different operation. So you're only down to multiplication and division. What would I need to do? Multiply to get the A's to cancel, or divide? Divide. I'm going to divide. 15 divided by 45 is 1/3. A divided by A is technically 1, but it's going to be 1 times something, so it might as well just cancel. And then exponent rule is b to the first divided by b squared. What does the exponent rule say you do when you subtract? So what's 1 minus 2? -1. Okay? And then we just need to get b all by itself. So what power can I raise this to So that when I multiply -1 times the power, like power times power, you multiply, it'll just be 1. Andrew? -1. So I raise both sides to -1. So the right-hand side is just b. And what is 1/3 to the negative first power? What does a negative do to a fraction? Flips it. So it's just going to be 3 to the first power, which is 3. So b equals 3. Now that I know that, just like any other type of problem, I can go back in one of the two originals and I can use b as 3. So 15 equals a times 3 to the first power. And 3 to the first power is just 3. And then I divide both sides by 3, and a equals 5. And so my final equation is f of x equals a is 5, and then b is 3 to the x power. Yes. Right, yep. So I'm going to talk about that right now because I told you I was going to do this as if it's the most complicated this type of question can ever become. If you have two completely random points on your curve, this is the way to do it. The points you are given here are not completely random because they're consecutive, 0 to 1 to 2 to 3, you can see what your multiplier is, right? What's the pattern? Times 3, times 3, times 3, times 3. Hey, guess what? That's your base. And your a, like we just talked about, is your y-intercept. When x is 0, well, you were given when x is 0, your y-intercept is 5. There's your a. Okay? Does that make sense? All right. So we're done. This could have been done that easily. Here's my y-intercept. Here's my base, times 3 times 3 times 3, of course. And I would want you to do it that simple now that you know. I just wanted to teach you that because that's what you'll have to use in an event where you aren't conveniently given this y-intercept and the pattern. Like, on the back, let's go here. You're given 2 points, 4, 3. So I'm going to write, here's my y equals b to the x. I'm going to plug in 4, 3 for my x and y as 1 point. And I'm going to plug in 648 for my other. Oh, I forgot my a. It's a times b to the x. Sorry. A times b to the 4th. And a times b to the 6th. Sorry. This reminds me, for our flashcards, we need to add the parent graph of exponentials. Exponential parent graph, and you need to know what the equation for that is. Y equals a times b to the x, and you need to know the sketch of that, which is 0, 1, 1 comma b, and I should see that your x-axis is an asymptote. Okay? Anyway, what operation are we supposed to do here? Division. So when I divide, 3 over 48 is 1/16. A over A cancels. And what is this? B to the negative second. So this might be a little bit trickier. What am I raising both sides to? Nope, I want the exponent to end up being b to the first. So negative 2 times what would give me 1? You could, if you want to do it in 2 steps. Here's the general rule of how you're always going to get rid of that exponent in 1 step. Use the reciprocal. If you multiply by the reciprocal, you always get 1. So that would be negative 1/2 on both sides. 1 second, Nathan. What's that? Yeah, that's what, I don't know if you remember this from little kid school, but multiplicative inverse, that's what that is. It's what you multiply by to get 1. It's the reciprocal, the multiplicative inverse. So when you multiply that on the right, you get b equals, what does the negative do to the fraction? Flips it, so it's just 16 to the 1/2 power, which is, what's 16 to the 1/2 power? Because raising to the 1/2 is the same as taking the square root, so that is just 4. So kind of Mason, we kind of did do that. The negative gets rid of the fraction, and the square root is the 1/2 power, yeah. Okay, so that, we don't really need to go any further with that. B is 4. Okay? All right, go back to exercise 2. They're giving us 2 points here, so let's use shortcuts if we can. What value, A or B, do you already know and why? Maggie. A is what? What number? 8. Because they're giving you the y-intercept. So you already know that A is 8. Now, so we don't really need a system here. If you already know one of the A's or B's, you don't need a system. Now all we need to do is plug in the point 3 1,000 and solve for B. So that'll be 1,000 equals 8 times b to the 3rd. Now, what do we have to do here first before we address the 3 as the exponent? Get rid of the 8. You have to. Get the 8 out of there, divide both sides by 8. So b to the 3rd equals, on your calculator, 1,000 divided by 8, 125. And what's the reciprocal of 3? 1/3. So we're raising both sides to the 1/3 power. Raising to the 1/3 power is the same as taking what root? Cubed root, which is just 5 equals b. So writing our equation is now f of x equals the a value, which we already knew was 8, times the b value, which is 5, to the x power. Question of the century, why don't I write 40 to the x power? Micah? Right, the x as an exponent is only supposed to be given to the 5, not to the 8. If you made it 40 to the x power, now you would inadvertently be giving it to both. It's an order of operations thing. We can't multiply before we do exponents. So you would do 5 to the x power first, and whatever that answer is, you multiply by 8. So there's our equation, and now we're just finding f of 2. So plug in 2. And then we can kind of do this without our calculators to practice that order of operations. 5 squared comes first is 25. 25 times 8 is 200. Now, exercise 4, for the sake of your notes, is just talking you through this process. A is telling you to substitute your points in. B is telling you to divide these two equations. C is telling you to solve for B, and D is asking you to state the final equation. So we're just going to do this all below as just pretending the question is saying, write the function. Write the function. So I'm going to plug in 236. I'm going to plug in 121.5. And I'm going to divide. I don't know how you want to write your division in there, whatever makes sense to you. The 36 divided by 121.5 gross, maybe I'll just keep it 36 over 121.5 equals, your A's will always cancel. That's the beauty of this division. And it's going to be b to the what? Negative third. So what am I going to raise both sides to? Negative 1/3 on both sides. And this is surely calculator work. So now I guess I can use that decimal. And I'll just raise it to the negative 1/3 power. 1.5. And then once I know B, I just go back to either one of the originals. I'll go to this one. 36 equals some A value, now times 1.5 squared, and I'll figure out A. What do I have to do first? Square 1.5, which is 2.25, right? Divide both sides by 2.25, and A equals 16. So write your equation. F of x equals your A value of 16 times your B value of 1.5 to the x power. So what's my y-intercept? 16. What's my multiplier? 1.5. So just for the sake of thinking about this, you don't need to write this down. If I had a chart in front of me, and I was told 236, whoops, put my 36 there, and my 121.5, I could very easily fill in the rest of these. My y-intercept is 16, and then my multiplier is 1.5. So 16 times 1.5 is 24. And this next one, taking that 24 and multiplying by 1.5, should just be confirmation of the 36. And the 36 times 1.5 gives me 54. The 54 times 1.5 gives me 81. The 81 times 1.5 should just give me confirmation of the 121.5. Beautiful. Okay? Does this make sense? Know that your A is your y-intercept and your B is your multiplier. Exercise 5. Just saving time. What do we expect B to be? Not a negative. Your base is never allowed to be a negative. Right. Because again, think about that. If we were multiplying by a negative and a negative, these would flip back and forth between positive, negative, we can't do that. So we expect it to be a fraction between 0 and 1 because we see the decay. We expect our y-intercept to be between what two numbers? This doesn't really narrow it down. Yep. No, the base, the multiplier is the fraction, so this is definitely a fraction, but A, Andrew? Right, somewhere between 128, which is way up here, and a half, which is way down here. Like I said, it doesn't really narrow it down, but at least we know what to expect based on the location of those 2 points. Okay, let's do this one, which is, yes, a word problem, but you have all the skills. You just have to pull the points from the word problem. A bacterial colony is growing at an exponential rate. Growing, so what's B? Greater than 1. It is also known that after 4 hours, its population is 98. So there's 1 point. 4 hours, 98 bacteria. And after 9 hours, so 9 hours, 189 bacteria. Okay, they're just giving you your 2 points. Linear word problems did this too. But with a linear problem given 2 points, you'd have to calculate the slope and all that good stuff. This is a totally different beast because it's exponential growing. So now we're just going to set up our 2 equations. 98 equals A times B to the 4th, and 189 equals A times B to the 9th. Divide out. 98 divided by 189. Ooh, gross. I'm just going to keep it 98 over 189. A's cancel, equals B to the -5th. So what are we raising both sides to? -1/5. Good. Always raise the reciprocal, and then it's just straight up calculator work. So that number raised to the -1/5 power. What does it say to round B to? Oh, it doesn't really. Let's go 1.14. Yeah, we're going to talk about that in a second. So B is 1.14. We'll go back and find A. Now, I'm going to write down 1.14, but I'm actually going to use what's in my calculator. I'm going to take that number, raise it to the 4th power, get this 1.69 number. And again, I'm only going to write 1.69, but when I do my division, I'm going to do 98 divided by, and I'm going to take that exact long, crazy decimal. So A will be as accurate as it could possibly be, 57.9. So my equation, y equals 57.9 times 1.14 to the x. Now, I don't remember, it was in one class but not the other on Friday that we talked about this. My B is 1.14. Does anybody know what percentage that must be growing by then? 14%. Okay? Because if my base is 1, I'm not growing at all. I'm not shrinking at all, right? But it's all about how much beyond 1 it is. So if this is 1 plus 0.14, that means I'm growing by 14%. Curious question for you. What if my base was 0.96? Am I growing or decaying? By how much? 0.04. Do you follow that? So the rate at which you're growing is always going to boil down to how far away from 1 are you? Growing by 14%, in this one,